Hello students, welcome to another video. Today we will be solving Pure Mathematics paper 1 from October-November 2017, variant 11. Question number 1. A curve has equation y equals to 2x to the power 3 by 2 minus 3x minus 4x to the power half plus 4. Find the equation of the tangent to the curve at the point 4, 0. So we need to first differentiate this equation so that we can find the gradient when x is equals to 4. So 2x to the power 3 by 2, when you multiply 3 by 2 with 2, you get 3. And 3 by 2 minus 1 will give you half. And differentiating 3x will give you 3. 4x to the power half, when you multiply half with 4, you get 2. And half minus 1 is minus half. And 4 becomes 0. So when x equals to 4, dy by dx will be 3 times 4 to the power half minus 3 minus 2 over 4 to the power half. So it will be 6 minus 3 minus 1, which is equals to 2. So the required equation can be found with the help of y minus y1 equals mx minus x1, where y1 is 0 and x1 is 4 and the gradient we just found is 2. So the equation of the tangent should be y is equals to 2x minus 8. Question number 2. A function f is defined by f of x is equals to x cubed minus x square minus 8x plus 5 for x is less than a. It is given that f is an increasing function. Find the largest possible value of the constant a. So we need to differentiate the function and we get 3x square minus 2x minus 8. By doing middle term break, we get 3x square minus 6x plus 4x minus 8. And then we take 3x common and we get x minus 2. And then we take 4 common and then again we get x minus 2. So the factors are 3x plus 4 and x minus 2. So let's first find where do we have the stationary values. So the stationary value lies when the gradient is 0. So x will be negative 4 over 3 and x will be 2. So these are the two stationary points. And since this polynomial equation is a positive polynomial equation, so the x cube graph will look something like this. And therefore, the maximum point will be at negative 4, 3. When x is negative 4 over 3, we will have the maximum, and when x is equals to 2, we will get the minimum point. So for the increasing function, that means when the gradient is positive. The gradient is positive only when x is less than minus 4 by 3. That means this side we have the positive gradient. And between negative 4 by 3 and 2, we have negative gradient. And again, after 2, when x is greater than 2, we again have positive gradient. So x is less than minus 4 by 3 and x is greater than 2. But since the question says that x is less than a, so x will be just less than minus 4 over 3. Question number 3, part A. It says a geometric progression has first term 3a and common ratio r. A second geometric progression has first term a and common ratio minus 2r. The two progressions have the same sum to infinity. Find the value of r. So for the first geometric progression, the first term is 3a, the common ratio is r. So sum to infinity for the first geometric progression should be 3a over 1 minus r. And for the second geometric progression, the first term is a and the common ratio is negative 2r. So the sum to infinity for this should be a over 1 plus 2r. According to the question, these sum to infinities for both of the progressions are equal. So 3a by 1 minus r is equal to a over 1 plus 2r. Now we can divide both sides by a and simplify it. So we will get rid of a by doing that. So now we have 3 over 1 minus r equals 1 by 1 plus 2r. If we cross multiply them, we get 3 plus 6r is equals to 1 minus r. Therefore, 7r is equals to negative 2. So r should be negative 2 over 7. For part B, it says the first two terms of an arithmetic progression are 15 and 19, respectively. The first two terms of a second arithmetic progression are 420 and 415, respectively. The two progressions have the same sum of the first n terms. Find the value of n. So for the first arithmetic progression, first term is 15 and the second term, which is a plus d, is 19. So we can find d with the help of these two information. Therefore, we can say, since a is 15, we can write it as 15 plus d is equals to 19. Therefore, d is 4. For the second arithmetic progression, a is 420, which is the first term, and the second term, which is a plus d, should be 415. With the help of this information, we can find d. So 420 plus d is 415. Therefore, d is equals to negative 5. Since the two progressions have the same sum of the first n terms, so what we can do, let's first find the sum of n terms for each of the cases. Sum of n terms, the formula is n by 2 within brackets 2a plus n minus 1 into d. So for this case, it will be 2 times 15 plus n minus 1 times 4. So n by 2 within brackets 30 plus 4n minus 4. Simplifying it, we get n over 2 within brackets 4n plus 26. And for the second arithmetic progression, sum of n terms will be n over 2 within brackets 2 times 420 plus n minus 1 times negative 5. So it will be n over 2 within brackets 840 minus 5n plus 5. So that will be n over 2 within brackets 845 minus 5n. According to the question, these two are equal. So we can divide both sides by n over 2, and this becomes 4n plus 286 equals to 845 minus 5n. Therefore, 9n is equals to 819. That means n is 91. Question number 4. Machines in a factory make cardboard cones of base radius r centimeter and the vertical height 8 centimeter. The volume V centimeter cube of such a cone is given by V is equals to 1/3 of pi r square h. The machines produce cones for which h plus r is equals to 18. We need to show that V is equals to 6 pi r square minus 1/3 of pi r cube. So it's given that h plus r is equals to 18. So we can make h the subject and write it as 18 minus r. The reason we are doing that, because we can clearly see that the part where we need to show that V is equals to this, there is no h in the equation. So that is the reason why we have made h the subject and expressed it in terms of r. Now we can say that the volume of the cone, as we know, is 1/3 pi r square h, where h is 18 minus r. So if we multiply, we get 6 pi r square minus 1/3 of pi r cube. For part 2, it says, given that r can vary, find the non-zero value of r for which V has a stationary value and show that the stationary value is a maximum. So we have already proved that V is equals to 6 pi r square minus 1/3 pi r cube. So differentiating it, we get 2 times 6 is 12 pi r and the power becomes 1 minus 3 times 1/3 is just 1 pi r, 3 minus 1 is 2. We know that at stationary value, dV by dr should be 0. So 12 pi r minus pi r square is equals to 0. If we take pi r common, we get 12 minus r is equals to 0. So r will be 0 or r will be 12. But since r is greater than 0, as the question stated, that find the non-zero value of r. So that means r is not equal to 0. So r must be 12. Now, again, dV by dr is 12 pi r minus pi r square. So the second derivative will be just 12 pi minus 2 pi r. So when r is equals to 12, the second derivative should be 12 pi minus 2 pi within brackets 12. So that gives us negative 12 pi. So since it's a negative value, our second derivative is less than 0. That means it's a maximum point. In part 3, it says, find the maximum volume of a cone that can be made by these machines. We have already found that the stationary value, which is the maximum, that happens when r is equals to 12. And we know the equation for v, which is 6 pi r square minus 1/3 pi r cube. So what we need to do, we just simply need to substitute the value r equals to 12 into this equation to find the maximum volume of the cone. So v is equals to 6 pi 12 square minus 1/3 pi 12 cube. That gives us 288 pi, and in three significant figures, that is 905. Question number 5. It says, the diagram shows an isosceles triangle ABC in which AC is equals to 16 and AB is equals to BC is equals to 10. So the circular arcs BE and BD have centers A and C respectively. So for the arc BE, A is the center, and for the arc BD, C is the center. And it also says where D and E lie on AC. We need to show that angle BAC is 0.6435 radians, corrected to 4 decimal places. So cos BAC, this angle, we are using the cosine rule over here. So cos BAC is equals to 10 square plus 16 square minus 10 square over 2 times 10 into 16. So cos BAC will be 4 over 5. Therefore, BAC should be cos inverse of 4 over 5. Therefore, B is equals to 0.6435 radians. For part 2, it says find the area of the shaded region. So the shaded region that they're talking about is of this diagram. So in order to solve this, what we can do, we can make another diagram and we can use the help of this. For example, for this particular diagram, we have BAF. The original question only had half of the diagram. So in order to solve this, we just created a new diagram, and BAF is equals to 2 BAC. So BAF is 2 times of BAC, and we have already proved what BAC is. So that means BAF should be 2 times of 0.6435, which is 1.287. So let's find the area of the minor segment BEF. Let's find this segment BEF. We know that the formula for the minor segment should be half r squared theta minus sine theta, where theta is in radians. So this minor segment can be found with the help of this formula, and that will give us 16.35011, and this theta is also 1.287. So area of the region BDFE, this whole region, since they are symmetrical, it must be twice of this, which is 2 times 16.35011. So the required area, what we need to do is we need to simply half this whole area, and then we will only be left with the area of the top, which is BDE. And BDE is the portion which is given in the question, and that is the shaded region that we are required to find, and that is 16.4. Question number 6. The points A 11 and B 59 lie on the curve 6y is equals to 5x square minus 18x plus 19. we need to show that the equation of the perpendicular bisector of AB is 2y is equals to 13 minus x. Let's first find the gradient of AB. So gradient of AB must be 9 minus 1 over 5 minus 1, which is 8 over 4. That gives us 2. Let's also find the midpoint of AB, because it says that we need to find the equation of the perpendicular bisector of AB, and that means the perpendicular bisector must be going through the midpoint of AB. So the midpoint of AB should be 1 plus 5 over 2 and 1 plus 9 over 2. That gives us 3, 5. So gradient of the perpendicular bisector must be minus 1 over the gradient of AB. So it will be minus 1 by 2. So the required equation is y minus y1 equals m minus x1, where y1 is 5, which is this, and the gradient is minus half, and x is equals to x1 is 3. So cross multiplying this, we get 2y minus 10 is equals to minus x, minus minus will become plus 3. So 2y is equals to therefore 13 minus x. In part 2, it says the perpendicular bisector of AB meets the curve at C and D. Find by calculation the distance CD, giving your answer in the form square root of P over Q, where P and Q are integers. So the equation 6y equals to 5x square minus 18x plus 19 is the equation of the curve. And the equation of the perpendicular bisector is 2y is equals to 13 minus x. Now, since they will be meeting at the point C and D, that means we need to equate these two equations. But before doing that, what we also can do, I can see that we have 6y over here and 2y over here. So in order to equate them, I've thought of first multiplying the equation 2 with 3. And that gives us 6y is equals to 39 minus 3x. Now we can simply equate 6y equals to 6y. So that will be 5x square minus 18x plus 19 is equals to 39 minus 3x. So 5x square minus 18x plus 3x plus 19 minus 39 is equal to 0. 5x square minus 15x minus 20 is equals to 0. So now we can simplify it further by dividing both sides by 5, as I can clearly see that these are all multiples of 5. So we can write it as 6x square minus 3x minus 4 is equals to 0. Then we can do middle term break, so that will be x square minus 4x plus x minus 4 is equals to 0. Then we can take x common and it becomes x minus 4 plus 1, and then we have x minus 4. So the factors are x plus 1 and x minus 4. That means x is negative 1 and x is positive 4. So now we can simply substitute these two values into the equations. So using equation 2, so the equation 2 is this, and it is easier for us to figure out the value of y with the help of equation 2. So when x is equals to negative 1, 2y is equals to 13 minus 1. That gives us y is equals to 7. And when x is equals to 4, 2y is equals to 13 minus 4. That gives us y is equals to 9 over 2. So the required distance, we can use the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. So we have the coordinates now. The coordinates are minus 1, 7 and 4, 9 over 2. So that will be 4 plus 1 whole square plus 9 over 2 minus 7 whole square. And that gives us 25 plus 25 over 4. So since we are told that we need to express this in this format where p and q are integers, so the final answer would be square root of 125 over 4. Question number 7, part A. The diagram shows part of the graph y is equals to a plus b sin x. We need to find the values of the constants a and b. So since it's a graph of sin x, the default grid of sin x is 0, 1, 0, minus 1. And we can see that we have a amplitude of 3. The difference between 1 and -2 is 3. So multiplying all the values with 3, we get 0, 3, 0, -3. And then we can also see that we have -2 as the baseline. That means we need to subtract all the values with -2. So -2, this will be -2, this will be 3 minus 2 is 1, and this will be -2, and -3 minus 2 is -5. So we can now understand that the amplitude is 3 and the translation, the vertical translation is -2. Therefore, A is -2 and B is 3. You can do this directly. This is just for part of explanation. Part B. The question says, show that the equation sine theta plus 2 cos theta times 1 plus sine theta minus cos theta is equal to sine theta within brackets 1 plus cos theta. This can be expressed as 3 cos squared theta minus 2 cos theta minus 1 equals to 0. So let's first expand this equation. By expanding it, first we need to multiply sine theta with all the elements inside this bracket, and then we need to multiply 2 cos theta again with all the elements inside this bracket. So that gives us sine theta plus sine squared theta minus sine theta cos theta plus 2 cos theta plus 2 sine theta cos theta minus 2 cos squared theta equals to sine theta times 1 is sine theta, and sine theta cos theta will be plus sine theta cos theta. Now we can cancel out all the positive negative values. So we are left with sine squared theta plus 2 cos theta minus 2 cos squared theta. And we can see that the expression that they are looking for does not contain any sine theta or sine squared theta. So we can manipulate sine squared theta as 1 minus cos squared theta and leave these two the way it is. Now again, simplifying this further, we get 1 plus 2 cos theta minus 3 cos squared theta equals to 0. Now if we multiply both sides by -1, we get 3 cos squared theta minus 2 cos theta minus 1 equals to 0. And that's how we have just expressed it into this form. Part 2, it says, hence solve this equation. So we know that this equation can be expressed as 3 cos squared theta minus 2 cos theta minus 1 equals to 0. And we can also see that it's a quadratic equation. So let's make it simple and consider y to be cos theta. So we can rewrite it as 3y square minus 2y minus 1 equals to 0. Then we can do middle term break and we get 3y square minus 3y plus y minus 1 equals to 0. We can take 3y common and that gives us minus 1 within brackets plus 1, again y minus 1 within brackets. So the factors are 3y plus 1 and 3y and y minus 1. So y should be -1 over 3 and y should be 1. Which means cos theta is equals to -1/3 and cos theta is +1. Let's first find the basic angle. So alpha will be cos inverse of +1/3, which gives us 70.529. And since we have -1/3, that means since cos is negative, that means it lies in the second and third quadrant. And for this, we also need to check what are the limits. The limit says that we can go clockwise up to -180 and anti-clockwise up to 180. So let's first find the negative value. So the negative value will be 180 minus 70.529 gives us 109.47. But since it goes clockwise, therefore it will be -109.47. And to get the value of the second quadrant, we again take away 70.529 from 180, and that gives us +109.47. And when cos theta is equals to 1, let's first find the basic angle. So basic angle alpha is equal to cos inverse of +1. So alpha is equals to 0. Alpha is 0, so that means we have positive cos. So it will lie in the first quadrant and the fourth quadrant. So theta will be 0 and theta will be 0 both clockwise and anti-clockwise from this point. So the angles are minus 109.5, 0 and positive 109.5. Question number 8 is not in the syllabus at the moment. Question number 9. Functions f and g are defined for x is greater than 3 by f of x is 1 over x square minus 9 and g of x is 2x minus 3. Find and simplify an expression for g of x. So g of x should be 2, and we need to substitute g of x again into x, which gives us 2x minus 3 within brackets minus 3. So simplifying it, we get 4x minus 6 minus 3, which is 4x minus 9. For part 2, it says find an expression for f inverse of x, and we need to state the domain of f inverse. So f of x is 1 over x square minus 9. Let's consider y is equals to f of x. So y is equals to 1 over x square minus 9. Now let's make x square minus 9 the subject of the equation. That gives us 1 over 9. So x square is 1 over 9 plus 9. That means x is plus minus square root of 1 over y plus 9. So f inverse of y is equal to x. That means f inverse of y is equal to plus minus square root of 1 over y plus 9. So f inverse of x must be plus minus square root of 1 over x plus 9. We know that domain of f inverse is equal to range of f of x. So let's first find the range of f of x. So f of x has the equation 1 over x square minus 9. And we know that the graph of 1 over x square for the positive side of x will look something like this. So when x is greater than 3, which is the domain of f of x, the range must be greater than 0 as well. The y values will be greater than 0 as well. That means that the domain of f inverse must be x is greater than 0. For part 3, it says solve the equation f g of x equals to 1 over 7. So f of x is 1 over x square minus 9 and g of x is 2x minus 3. So f g of x must be 1 over 2x minus 3 whole square minus 9. Simplifying it, we get 1 over 4x square minus 12x plus 9 minus 9. And that gives us 1 over 4x square minus 12x. It's given that fg of x is 1 over 7. So fg of x is equals to 1 over 7. Therefore, 1 over 4x square minus 12x is equal to 1 over 7. Cross multiplying it, we get 4x square minus 12x equals to 7, which is 4x square minus 12x minus 7 is equals to 0. By doing middle term break, we get 4x square minus 14x plus 2x minus 7 is equals to 0. If we take 2x common, we get 2x minus 7, and plus 1 will give us again 2x minus 7. So the factors are 2x plus 1 and 2x minus 7 equals to 0. Therefore, x must be negative half and x will be 7 over 2. But since x is greater than 3, x must be 7 over 2. Question number 10. The diagram shows part of the curve y is equals to half of x to the power 4 minus 1, which is defined for x is greater or equal to 0. For the first part of the question, we need to find, showing all necessary working, the area of the shaded region. So the equation of the curve is y is equals to half x to the power 4 minus 1. So integrating y with respect to x, we get half. We can take half outside of integration because it's a constant, and we can simply just integrate x to the power 4 minus 1. So splitting this, we get half integrating x to the power 4, and again if we take half outside, and we just need to integrate 1. So when we integrate x to the power 4, we get 4 plus 1, which is 5, and 5 in the denominator. Also, when we integrate 1, we get just x. So it will be half times x to the power 5 over 5 minus half times x. So since we have the limits as 1 and 0, we can use those limits to find the area of the shaded region. So the equation we got by integrating is x to the power 5 over 10 minus x over 2. Now substituting these two values will be 1 over 10 minus 1 over 2 minus 0 over 10 minus 0 over 2. And we will be getting 0.4. For part 2, it says find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degree about the x-axis. So for that we need to find y square, because the equation that we need to find the volume of rotation obtained by rotation is v is equals to pi integrating y squared dx. We know that y is equals to half of x to the power 4 minus 1. So if I square both sides of the equation, we get y square equals to 1 by 4 and x to the power 4 minus 1 whole square. So v is equals to pi integrating with the limits 1 and 0, 1 4 x to the power 4 minus 1 whole square. We can take 1 by 4 outside because it's a constant, and we can simply just integrate this. But before integrating, since we have a square over here, we can expand it with the help of a minus b whole square, and that gives us x to the power 8 minus 2x to the power 4 plus 1. Now we have 1 over 4 times pi, and the limits we have 1 0. Now if we integrate this equation, we get x to the power 9 over 9 minus 2x to the power 5 over 5 plus x. Now substituting these two values 1 and 0, we get 1 over 4 times pi, and then we have 1 to the power 9 is 1 over 9 minus 2 times 1 to the power 5 is just 2 over 5 plus 1 minus 0 over 9 minus 0 over 5 plus 0. So this will be, simplifying it, we will be getting pi by 4 times 32 over 45. Simplifying it further, we get 8 pi over 45, which is 0.559. For part 3, it says find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degree about the y-axis. So y is equals to half of x to the power 4 minus 1. In the previous part of the question, we had to find the volume obtained by rotating about the x-axis. And now we need to find the volume obtained by rotating about the y-axis. So previously it was x-axis, now it's y-axis. Again, for this, what we need to do, we need to make x squared the subject of the formula, because now the volume will be obtained by rotating it about the y-axis. So let's first make x the subject of the equation, and we also need to make square it. So 2y is equals to x to the power 4 minus 1. That means x to the power 4 must be 2y plus 1. Now if I square root both sides, I get x square is equals to square root of 2y plus 1. Or we can say that x square is equal to 2y plus 1 to the power half. So the volume obtained by rotating about the y-axis, the formula will be pi integrating x squared dy. So the volume will be pi times minus x squared dy. The reason we introduced this minus is because the upper limit is negative half and the lower limit is 0. But we know that the upper limit must have a higher value. So in order to flip these values, we have to introduce negative. So we can take the negative outside and this becomes negative pi. And we are left with x square. And x square is 2y plus 1 to the power half. So 2y plus 1 to the power half. So for this, we have power as the operator. So minus x square is minus 2y plus 1 within brackets to the power half. So power is the operator. So we need to differentiate the elements within the brackets, and that gives us 2. So we bring 2 over here and we balance the equation again by multiplying with half outside. Then we are left with integrating the power only, which gives us half plus 1 is 3 over 2. In the denominator, we will have 3 over 2. So it will be minus this half and then 2y plus 1 to the power 3 by 2 over 3 by 2. So that means, simplifying it, we will be getting pi times, within modulus, we have minus half times 2/3. So I'm cross multiplying this. I'm multiplying with the reciprocal of this, which is 2/3, times 2y plus 1 to the power 3 by 2. And we have the limits 0 and minus half. Now we can simply substitute these two values and we get minus 1 over 3 times 1, because when you are substituting 0 over here, this will just become 1 and this will become, this 2 and 2 will cancel out and we are left with minus 1 over 3. And when you are substituting minus half into this equation, it becomes 2 times minus half will give you minus 1. So minus 1 plus 1 is 0. And this will be minus 1 by 3. So minus 1 by 3 times 0 is 0. So the whole thing within the modulus will be negative 1/3. So eventually it will become positive pi over 3, which is 1.05. And that will be all for now. I will see you in the next video.